All right. We are not. We are not quite done with this first lecture. I was fooled because when I clicked on a certain window, nothing happened because I was on the wrong window. I feel silly. All right. So, physical properties and changes. Okay. A physical process changes the form of a substance, but not from one substance to another. So, for example, liquid water changes to gaseous steam when you boil it. It's still H2O the entire time. You take a rock, you hit it with a hammer, you'll break it down into gravel. Okay? That's still just a physical change. You take your salad with gross stuff in it and you pull the tomatoes out, put them in the garbage where they belong. That's a physical process. Okay? Now, a physical property is a value or quality of the substance or mixture, possibly in itself. It can be measured without changing the substance into another substance. So, for example, mass, volume, color, how awful tomatoes are. These are all physical properties. Mass is the measure of the amount of matter in the object. Volume is a measure of how much space the object takes up. Color is the response of the object to light. Okay? These are all physical properties. Now, physical properties, again, come in different varieties, extensive or intensive. Now, an extensive property depends on how much of the substance is present. Okay, you look at it from the exterior. The bigger the object, the more exterior it has. That might be one way to think of it. Or the extent of the stuff. Greater extent means greater expanse, means greater volume size, things like that. Okay, so volume and mass are both extensive physical properties. If you have more of the substance, it's going to have more mass. It's going to take up more space. Intensive properties are independent of the amount of substance. So they're sort of like inside the substance or mixture. Okay? So temperature and density are both intensive properties. Okay? A 10-gram pebble will be at the same temperature as a 10-kilogram stone or a 10-ton boulder, right? And they'll all have the same density. Where density is a ratio of extensive properties. That is sometimes the case, not always, but a ratio of extensive properties will often end up being an intensive property. If you're picking your properties carefully. If you're just picking random crap, then who knows? But density is the ratio of mass to volume. So this is a little bit of math, and this is a popular kind of math because it's pretty necessary. Density equals mass over volume. You're going to need to be able to do algebra for this class, so this is the sort of manipulation you're going to need to be good at. D equals m over v. So you rearrange that a little bit. You multiply both sides by volume. You're going to get density times volume equals mass. Then you can rearrange again, divide both sides by density. And what you're going to end up with is volume is equal to mass over density. Okay. Being able to manipulate and work with equations like that is going to be super duper valuable. So I recommend, if you're a little bit shaky on that sort of algebra, that you spend some time practicing it. Google is your friend there. That seems like it probably won't be too intrusive. My dog is chewing on a bone. All right. Go ahead and practice your algebra. Google is your friend. Practice algebra, right? And you will come up with tons and tons of different things programmed with Java because nerds are fancy like that, and you'll get some practice with that. Okay. So anyway, intensive versus extensive. Intensive property is independent of the amount of stuff. An extensive property is dependent on the amount of stuff. Okay. Mass and volume are the two really popular, the two main extensive properties you're going to have to concern yourself with. Temperature and density are going to be some of the bigger, more important intensive properties. Really, though, this is kind of a thing that shows up on the first test and doesn't matter excessively, but it's something you're going to need to know, if only for the test. So, chemical processes, chemical changes, chemical properties. Okay, a chemical process involves the change of a substance into one or more different substances. So, when iron rusts, that is a chemical process. That is iron chemically reacting with oxygen in its surroundings in order to form iron oxide, rust. Okay. Limestone, or calcium carbonate, you heat that up enough and it will break down into calcium oxide and carbon dioxide. It will actually release a gas. Okay. And then you can combine quicklime, or calcium oxide, with water to produce a substance known as slaked lime, or calcium hydroxide. These are all chemical processes. Iron rusting is one substance, or is two substances combining to form one new substance. Heating up limestone, that was a decomposition. One substance broke down into two substances. Okay? And then, slaking that quicklime is again a combination of two substances into a single substance. But you can go more complicated than that. So, for example, combustion. Okay, if you take propane, you want to talk about propane? Propane accessories? Combine propane with oxygen, you're going to get carbon dioxide and water. You're going to learn a lot about how to read these formulas and these chemical equations. But for now, just sort of accept that this is propane, that's oxygen, that's carbon dioxide, and that's water. Two substances combining to make two substances with different amounts of each substance required and produced. Okay. So chemical processes always involve a change from one kind of thing to another kind of thing, from one substance into another substance. They're going to have different chemical and physical properties. Propane is a gas at room temperature. It's a gas that will react with oxygen to produce CO2 and water and release a lot of heat. That's why we use it. We burn it, for grilling or, heating. Oxygen is a highly reactive substance. It forms about, 20% of the atmosphere. It's necessary for animal life and so on. CO2 and water, on the other hand, have very low reactivity. They don't react very much at all. They have both, they don't burn because they've already been burned, sort of thing. They're both smaller molecules than propane. They're both a little bit larger, physically that is. CO2 is going to be a gas at room temperature. Water will be a liquid at room temperature, unlike either of these. There's a whole lot of different sorts of properties we can talk about when it comes to these different kinds of substances. Okay, I'm going to have to kick the dog out. Hold on, this will take about a second. Hey, Wesley, come on, buddy. That's right. Good boy. Now let's get your bone. Ooh, come on. You're such a good boy. You're such a good boy. Yes, you are. I'll go at the door. I hate to do it, but he is a very loud bone chewer. All right, so continuing with chemical properties and so on. A chemical property is a value or quality of the substance that allows it to change into other substances. Okay. So the thing about a chemical property is that you can only measure it by changing the substance into another substance. Okay. So the ability of salt to dissolve in water, that's a physical property, not a chemical property. That's complicated. Ignore that one for the moment. But the ability of hydrogen peroxide to decompose spontaneously into water and oxygen, that is a chemical property. It will always do that just sort of spontaneously by itself. Likewise, diamond will always spontaneously transform into graphite. So you don't always have to have another substance present in order to have a chemical property be around. The fact that propane reacts with oxygen is a chemical property. The fact that sodium will react with chlorine is a chemical property. The fact that hydrogen peroxide decomposes into water and oxygen is a chemical property. Now, diamond turning into graphite looks strange because it's going from pure carbon to pure carbon. Those are what are known as allotropes, different arrangements of the carbon atoms. Carbon as a diamond is a single every carbon atom is bound to 4 other carbon atoms with chemical bonds into a 3-dimensional structure. Whereas carbon as graphite, every carbon atom is only bound to 3 other carbon atoms in a 2-dimensional sheet. They are different structures, different physical and chemical properties when they are these 2 different arrangements. So we treat them as 2 different substances. Pure carbon in either case, but very, very different forms of it. All right, so chemical process involves a change of 1 or more substances into 1 or more different substances. A chemical property is the properties that allow for those sorts of changes. So going back to mixtures versus compounds, a mixture can be separated physically, and the components can have any ratio within limits. A compound can be only be separated chemically, and they exist in strict ratios. So those physical separations could be centrifuge, distillation, just using tweezers to pick the things apart. So salt water, H2O with salt in it, can go from anywhere from 0. Oh, I was closer to the second guess. 0 grams per liter, pure water, up to 360 grams per liter. That's when the salt is saturated in the water. Okay. Compounds can be separated chemically, and they can only be separated chemically. Now, heat can be a trigger for chemical processes, just as it can be a trigger for a physical process. Okay. When it comes to those strict ratios, that rule is bent for alloys. Alloys are when you combine things with metals. So steel is an alloy of iron and carbon. Although if you want to get fancy, you can bring in other things, like stainless steel is iron and carbon and I think nickel, vanadium, maybe a little bit of molybdenum. I mean, they put in a lot of stuff in there to make sure that it's, as unreactive as possible. Gold in jewelry is typically not pure gold, but is instead going to be an alloy of gold and copper. Okay. Alloys, they sort of bend the rules. They're sort of somewhere in between being a compound and a mixture. They're really, really neat, but we're not going to discuss them in this class. So you can kind of ignore most of that and just focus on the vast majority of the chemical compounds that we care about, which do exist in those straightforward ratios, where you'll see an element with a subscript that tells you how many atoms of that element there are in the compound. Then the next element, number of atoms, next element, number of atoms, and so on. So, compound, again, is 2 or more elements, and an element is the smallest unit chemically. It cannot be broken down into a simpler substance through chemical means. It can be broken down through nuclear means, but not through chemical means. Okay? Every particle of an element, the smallest unit of matter for an element, is the atom. Okay? And we'll get into that more later. But for now, that is it, finally, for this first lecture. Chapter 1, Lecture 1, talking about the different kinds of matter. Okay. And now, we'll see you for Lecture